Hello and welcome. In this video, we're going to be looking at graphing a linear inequality. So to start this process, we're going to take this inequality and we're going to actually graph the equation that's analogous to it. Because what I'd like to know first is where are the x and y coordinates where x minus 2y equals negative 2. Okay, so I've just written out our first step, so we want to graph out x minus 2y equals negative 2. So there's lots of ways we can do this. I'm just going to make an xy table, and I'm going to use intercepts to do it. So if I plug 0 in for x, that leaves me with negative 2y equals negative 2. Divide both sides by negative 2, and that gives me y equals 1. If I plug 0 in for y, on the other hand, then the equation becomes x equals negative 2. And now I've got 2 points, and that's really all I need in order to graph out this line. So we could have also put the equation in slope-intercept form. We could have also picked just values to plug in for x, but this works just fine. So 0, 1 is one of my points, and then negative 2, 0 is another point. So the graph is going to go, whoops, missed a little bit there. Okay, so it's going to go through those 2 points. So what that line represents is, again, it tells me the x and y coordinates where x minus 2y equals negative 2. Well, my job is to graph out the x and y coordinates where x minus 2y is less than or equal to negative 2. So that means that this line that I drew should count in my solution because it does include equality. But I also want to graph out some other points as well. So step 2 is you'll notice I have a bottom half of my line and I have a top half of my line. So in other words, I have an area below and an area above. What I want to pick is a test point either below or above my line to see if when I plug in the x and y coordinates, if it produces a true statement or a false statement. Okay, so I've written out our step 2. So we want to choose a test point that's not on the line. Why don't I want to pick a test point on the line? Well, I already know that if I take a point from the line and plug it in, that it's going to give me a value where x minus 2y is equal to negative 2. So I want to choose a point that's not on the line. So you'll notice that I've made this little green dot, and notice that that's a point below the line. Okay, also for just demonstration, I'm also going to pick a point above the line as well, just to demonstrate again what kind of happens here. So you'll notice I've got 0, 1 is right on my line. 0, 2, this point up here, is not on the line. So I'm going to test that one as well. So the green dot is at 0, 0. That's below the line. And then the blue point is at 0, 2. That's above the line. Okay, so what I want to do then is I want to take the 0, 0. I'm going to plug this 0 in for x. I'm going to plug this 0 in for y. And I want to see if I get a true statement or a false statement. So here we go. So I'm going to plug this 0 in for x. That gives me 0 minus, plug this 0 in for y. 2 times 0 is less than or equal to negative 2. That's really what I'm checking, so I'm going to put a question mark through it. Well, if we do the math on the left-hand side, 0 minus 2 times 0 is just 0. And then I've got less than or equal to negative 2. So the question is 0 less than or equal to negative 2? And the answer is no, this is false. Okay, if we check the blue point, well, I'm going to plug this 0 in for x. I'm going to plug this 2 in for y. That gives me 0 minus 2 times 2. And the question is that less than or equal to negative 2? Well, 0 minus 2 times 2 is negative 4. Is that less than or equal to negative 2? And the answer here is yes, this is a true statement. So what that tells me when I look at my graph is that I want to plot the points, I want to include all the points above the line as part of my solution, and I also want to include the line itself. So my final answer would be the line that I graphed in step 1, but I would also want to shade all of the area above that line as well as part of my solution. Okay, here's another one for you to try. Pause the video and then restart after you've given it a shot. Okay, so our first step again, just like before, is let's pretend that we have an equation rather than an inequality. So let's graph out this line. This time, because the line is in slope-intercept form, we're going to use that to our advantage when we do the graph. Okay, so here we go. If we plot out the line, well, we're starting at a y-intercept of 4. So I'm going to go up 4 on the y-axis. And then the slope is telling me to go up 2 over 3. So if I do that, up 2 over 3 takes me to about here. And then if I just plot the line through those 2 points, that gives me that. And now I want to pick a test point. And again, I can either pick a test point below the line or a test point above the line. I really don't need to test both, because if I find that it's false below the line, then I know it's true above. If I find that it's true below the line, I know that it's false above. It can't be true in both places. So let's just pick, I'm going to go to my old standby, which is if 0, 0 isn't on the line, that's the one I usually pick to test. So we're going to test 0, 0, and I want to test it in, again, the original inequality. So I'm just going to write that right below. So our original inequality was y is less than or equal to 2/3 x plus 4. And now I'm going to plug 0 in for x, and then this 0 is going to go in for y. So I get 0 is less than or equal to 2/3 times 0 plus 4. And I'm left with 0 is less than or equal to 2/3 times 0 is 0, plus 4 is 4. So 0 is less than or equal to 4. That is a true statement. That means 0, 0 should be included in my solution set. So my solution would include the line itself. Why does it include the line itself? Because I've got this equal to here, so I'm allowed to have y equals 2/3 x plus 4. So it includes the line itself as well as the points below the line. So my final solution would look like that. It would be the line, and then everything below would be shaded. So the question is, okay, what if you didn't have the equal to? What if you had something like y is less than 2/3 x plus 4? Then what would your solution look like? Well, the solution would actually look really similar to the one that we did. So I would still plot out my line, which would look something like it does back here. The only difference is I don't want to include the line itself as a solution. So how do I not include the line itself? Well, I would actually, instead of drawing a solid line, I would draw a dotted line, and then I would shade the points below. Dotted line indicates to your reader that you don't want to include the line itself.